In this tutorial, we're going to walk you through all the settings for the molding toolpath operation. Using the molding toolpath strategy, we can create toolpaths that have a consistent cross-section. 3D toolpaths are created without the need of a 3D model to ultimately give us a better finish and reduce the machining time. To start off, we're going to need to create a brand new file. And this is going to be a single-sided job. And the width is going to be 26 inches. And the height is going to be 6. And the thickness is going to be 3/4 of an inch. We're going to be zeroing off our material surface, and we're going to set our XY datum to the bottom left-hand corner. The modeling resolution is set to very high, but that doesn't matter at all because we're not ever going to be creating an actual 3D model. Then this could be set to anything you'd like. And then we're going to use Canadian maple as our appearance, and we're going to click OK. Now, in order to create a molding toolpath, you need at least one vector to extrude a cross-section along, and then of course you need your actual cross-section vector. So in this case, we're going to create a vector line to extrude a cross-section along, and we're going to start out with our X is 1 and our Y is 1, and we're going to add in a point, and then we're just going to use our smart cursor, and we're going to go over until we see the length of 24 inches. Then we're going to left click and then right click to get out of that form. And then we're going to need that cross-section. We've already pre-made a cross-section for you to look at. So we're going to go ahead and click on Import in Vectors. And we're going to choose this molding profile number 1 from your Molding Toolpaths tutorial folder. We'll click that and we'll click Open. And then we'll see down in our bottom left-hand corner, we have an actual cross-section. So just for a second, let's take a closer look at that cross-section. So we're going to zoom into the selected object by using this zoom button right here. And if we off click that vector, we're going to see that we have a nice looking piece of molding here. It's totally symmetrical. We have the height of this, which is 0.7 inches tall. And you can see that down here in the bottom. It's 4 inches wide by 0.7 inches tall. That's the actual, it's drawn to scale. So that's the actual finished height we want this piece of molding to be. And we have deliberately put in some flat areas so we can demonstrate how we can create some optimized tooling to get you nice, clean, flat areas in your molding by using some options in the molding toolpath that we'll get to later. So let's just press F on our keyboard to zoom back out again. And we're going to need to pop over to our Toolpaths tab in order to take a look at setting up this molding toolpath. So as always, the first thing we're going to want to do is look at our material setup to make sure that our software knows the actual physical setup on our machine. So the thickness is still going to be 3/4 of an inch. Our datum is to the bottom left-hand corner. We're still going to be zeroing off our material surface. And we're not going to worry about our model position because we don't have a 3D model. We're never going to have a 3D model created when we're using the molding toolpath. We're actually just going to create tooling based on these vectors. So this isn't important, and we'll set up the position of our actual toolpath when we go into the molding toolpath form. Our rapid Z gaps above our material and our home and start position, you'll need to set those up in a way that they're safe and appropriate for your machine and the material that you're using, and also any hold downs that you might be using to keep your material in position. So we're just going to go ahead and click OK here. Okay, so now that we have our material set up, it's time to go in and start to look at creating our molding toolpath. So to do that, we're going to go over to our Toolpaths tab and choose our molding toolpath. And this will open up our molding toolpath form. Right at the very top, we're going to see that we can select not only one drive rail, but 2 drive rails, or 3, or as many as you'd like. And then we need to follow that up by choosing our cross-section that we want to extrude along those drive rails. So that way you can make multiple molding parts if you would like to, maybe different shapes and so on. So let's go ahead and select our drive rail and hold down our Shift key and grab our cross-section. And right off the bat, you're going to see that our drive rail is going to go in this direction, and it's going to hang off of that our cross-section. So these red lines indicate the width of our actual cross-section we're going to use. So these are 4 inches. And also, you've probably already noticed too that they're hanging off the wrong side of our line. We really like to have them hanging up on our vector. So to do that, if we right-click on top of our drive rail, we can go ahead and choose reverse direction, and that will flip that over to the other side, which is perfect. Now, we happen to have a very symmetrical looking piece of molding here. If this wasn't symmetrical and you had to make sure that a certain end of this was hanging off of your line, then what you could do is right click on it and you can reverse the direction. You'll see that the green start point will change ends when you do that. So the next spot in our form is we need to tell the software where we'd like our toolpath to be placed with the inside of our material. And to do that, we can use our little drag handle here and we can drag it, and you'll see that our molding is represented by this light brown area and the extra material is this darker brown. And we can use the slider if you'd like, or you can actually type in values into the fields. In this case, we're going to put our molding right to the back of our material because the actual height of our vector that we drew is the 0.7 inches that we want. It's an exact thing. And then you'll see that our cut depth is the full depth, 0.75 of an inch, which is our material thickness. Now, our first tool that we're going to select, we're going to think of this as being our finishing tool, the last tool that we're going to run to clean up our part to make it look perfect. So we're going to go ahead and select that. And we're going to use a 1/8 inch ball nose end mill, and we're going to go with the settings that are here. But you're going to want to make sure you check those and be sure they're safe and appropriate for your machine and the material you're cutting into. Select that. We're going to unclick Vary Stepover, and we're not going to talk about any of this right now, and we're going to unclick that, and we're going to calculate this. So this is the very basic setup for this. We've taken that one drive rail, the one cross section, and we've told our software to make us a piece of molding using just one tool. And so you can see that we have a tool path, the full length of our vector drive rail, and then at the end of it, you can see the cross section. Now to get a better look at that, we can look right at our end of our material. We can go up in view and we'll turn off our color shaded view and we'll zoom in. So there you can see the actual shape that we're going to make based on that cross section vector that we used. And you can see how the tool is going to step down the sides of these shapes. Now you'll notice that when it comes to these highly radius parts, that because we're using a decent sized cutter for this, and also the Stepover is consistent, that we're going to get a bit of stepping going on along the edge of these radiuses. And we have an option in our software that we can use to reduce that a little bit. So let's go ahead and have a look at that. So let's go back up and go to view. We're going to turn back on our color shaded view. Let's look at our isometric view, and then double click on our toolpath so that we can have a look at this option. So right here, we have a checkbox underneath our finishing tool called Vary Stepover. So if we click that, and then we zoom in a little bit, and we're looking at this area right in here. If we recalculate that, you'll see that we now have more passes. So our Stepover has been tightened up as we travel over top of that radius there, and then it'll drop straight down and continue at the bottom of this flat area. So let's have a quick preview of that visible toolpath, and we'll see what we have. And that's what we expected to see, and that looks pretty good. So back to our ISO view again, and double click on that toolpath. And let's look at our next option, which is using a larger cutter before we go in with our finishing cutter and actually removing a bunch of materials so we don't put any extra forces on our smaller cutter. That may happen, or maybe we will even break a bit, and we don't want that to happen. So let's just use a larger clearance tool, and we're going to select that larger clearance tool, and we're going to use a 1/4 inch end mill. Again, we're just going to choose the basic settings that are there, and we'll select that. We do want it to machine the flat regions, and we're going to ramp in at 0.5 an inch, and we're going to leave some material behind so that we can come back in with our finishing pass and we can remove that material. And we're going to leave everything else the way it is, and we're going to go ahead and calculate that. Now in our toolpaths list, we now have 2 toolpaths. The first one is going to be our roughing pass, which is called Sweep Profile 1 Clear, and then the second one is our finishing pass. So let's turn off our finishing pass, reset our preview, and we'll see that our roughing pass is doing some big Stepovers here and removing lots of materials. Let's preview that toolpath and we'll see what we end up having. Looks pretty nice, I like that. And then we'll have a look at our finishing pass, and we'll preview that. And that looks really good. Let's go back to our options again by double-clicking on either one of these toolpaths. And the next thing we're going to look at is, what if we wanted our finishing pass to actually skip the flat areas that we've actually machined here? So if we click skip flat areas, and then let's just recalculate that, we're going to see something different when we look at our toolpaths. If we reset our preview and we're going to look at our finishing pass, you'll see how it doesn't recut those areas that we already cut with that nice end mill that we used. And obviously that'll save us some time in the end. So if we reset our preview and then we preview those visible toolpaths, both of them, we'll see that essentially we end up with exactly the same thing, but our finishing pass skipped over those areas that were already cut out with our end mill. Let's just go back into our toolpaths again. And we don't need to worry about create sharp corners. That's not important. But the boundary offset is, if we wanted to overcut the sides of our profile so that we could cut it out of our material, then we'd want to take advantage of this. So we could go ahead and use a number if we wanted to, like 0.2 of an inch. Or we could use our software to create an automatic boundary offset for us. So it depends on what you would rather do. You can get the software to do it for us, but in this case, we're actually going to type in a number and we'll recalculate that. And let's reset our preview, and let's preview all of our toolpaths again. And you'll see what happens on the outside edge. We actually cut through our material and we did our roughing pass so that we can maybe cut this out easier out of our material. It's good to note that when you choose the boundary offset option, either you type in your own boundary offset distance or you use the automatic boundary offset, that it only offsets on the sides of your profile that run parallel to your drive curve. So you can see that here, that it's only using the offset on the bottom and the top of our molding, because that's where our drive rail runs along. If we needed to, in the end, have this cut to a very specific length, because if we went in with our scroll saw or whatever we happen to use and cut this out, or a handsaw, then the ends of these might not be very straight. So let's have a look at how we can add one more toolpath to this, a profile toolpath, so we can cut this actually out of our material at a specific length. So let's close this down. Let's go back over to our 2D view for a second, and let's bring up our drawing tools. Okay, so to do this, we are going to off-click our vectors and we're going to select our drive rail. We're going to go into node mode by pressing N on our keyboard. We're going to select that last node, and we're just going to use our cursor keys on our keyboard to extend these two ends out a little bit, so we have a little extra length to work with. Okay, we're going to go ahead and draw a rectangle now, and we're going to make sure that our anchor points at the bottom left, our center points are at 0, 0, and we are going to make this 24 by 4 inches. So we'll create that, close that down, we'll select that, and we'll press F9 on our keyboard. And that should line up perfectly into the middle of our workspace. Let's go back over to our Toolpaths tab, and then we're going to recalculate our molding toolpath, because we've extended those lines, so we need to do that. So let's calculate those. Let's reset our preview, and let's preview our visible toolpaths. So now it's longer than what it was, but we're using the same settings as before. And now we're going to go in and actually cut this out. So let's close this down. We're going to flip back to our 2D view. Actually, we're going to tile our views, which makes it a bit easier for us to see. We're going to create a profile toolpath. We are going to start at 0, and we're going to go down the full depth. We are going to use a 1/4 inch end mill. Select that. We're going to choose this vector, and we're going to go on the outside of that line. And we're not going to do a separate last pass. We could add in some tabs if we'd like to. We might want to tab it at the end so that it won't fall out, but for our demonstration, we're not going to do that. And we're just going to go ahead and calculate that. And then if we preview our visible toolpath, you'll see that we actually cut that out of there. We can double click on our waste material, and there's the actual piece of molding that we're going to create, which looks really good. Now, one other thing I want to point out is that if we go back to our 2D view for a second, we can also choose to remove our legs off of our cross section. They don't need to be on here. So I'm just going to demonstrate that right quickly. So if we zoom into that selected object and we go into node mode and we just hover over this line and right click it, and we can delete that span. Same with over here, we can delete this span. And now if we go back into our toolpaths again, double click on this, you'll see that our position has now changed. So it's remembered that we want our top gap to be 0.5 and the remainder here is actually the 0.7. It's up to you how you draw this, but it is important that we point out that you don't need either one of those legs on there to use this particular option. So let's close this down. Go back to our 3D view. So as you can see, the molding toolpath has lots of options for you to help you come up with a nice, clean, finished cut without using a 3D model. Now let's just take a minute and let's compare what we'd see by actually cutting a 3D model compared to using the molding toolpath. So to do that, what we're going to do is we're going to go File and close this. We should probably save this off, and I'll save it off into your tutorials folder, and we'll call it Molding Toolpaths Example _1, and we'll save that so you can have a look at that later. So let's create a new file. And in this case, our new file is going to be 40 inches. It's going to be a single-sided job, but we're going to change the dimensions to be 40 by 12 by 1 inch thick. We're going to zero off our material surface. Bottom left is fine for our datum. The modeling resolution doesn't matter because we're not going to actually use a 3D model in this, so that's not so important. And our appearance is Canadian maple, and we'll click OK. Now we're going to need a drive rail to start with, so let's just draw an arc this time. And we're going to create a 3-point arc, and we're going to start out with an X of 4 and a Y of 1, and our endpoint is going to be 36 and 1. And then we're going to set a height of our arc to be 6 inches, and we'll click Create and Close. And again, we're going to need to import in a cross section, so let's just go ahead and do that. And in this case, we're going to use molding profile number 2 and open. Now if we zoom into that object that we just imported in, you'll see that it's a nice shaped vector profile with some flat areas, but it's missing one of those legs like I showed you in the end of the last video. You don't need those legs on there. The software will figure that out for us, so that's perfect. So let's zoom back out, so pressing F on our keyboard. Let's jump over to our molding toolpath, and we're going to go right into our molding toolpath. We're going to select our two vectors, so the arc, and holding down our shift key, the cross section. Now this is actually being hung the wrong way off our vector, so we're going to right click on that and reverse our directions. Going to take a look at our position of our molding in our material, and we're going to add a 0.05 inch gap at the top. That leaves us with 0.2 of an inch of material on the back. And we'll go ahead and select our finishing tool. In this case, we're going to use a nice big 1/4 inch ball nose. It's important for me to point out that we're not going to change any of these settings in our comparison. So when we compare this to what we're going to do with a 3D model, I'm using exactly the same tools. So we'll select that. We're going to use a large area clearance tool. We'll select that, and we'll use a 1/4 inch end mill. Select it. We will machine our flat areas. We're going to skip our flat areas here. We'll leave some material behind. Use an automatic boundary offset, and we'll calculate that. And we'll take a look at our toolpath. It looks quite nice. And then we'll preview these one at a time. So there is our roughing. And then we'll look at our finishing. Now that's a nice looking, smooth, finished part. All of our recesses are cut really quite nice. And it looks great. That's because our tool is actually following the arc that we created. And if we close this down and we have a look at the times to cut this, we'll see that it's going to take well, I changed our scale factor down to 1. You'll see that it's going to take about 1 hour and 20 minutes to cut this one piece of molding. So we're going to keep that in mind when we take a look at our next part. So let's flip over to Aspire. And in Aspire, I've created that same shape as a 3D model. And you can see the 3D model in our 3D view. This isn't a preview of the Toolpath. This is actually a real 3D model. And I've created tooling for it. So let's take a look at our roughing pass. Let's reset our preview and we'll preview our roughing pass. And then we'll go ahead and preview our finishing pass. And then to see it better, we're going to maximize our 3D view and have a look at this. So at first glance, it doesn't look so bad. But when we zoom in a little bit, because of the nature of how a raster 3D tooling works, we end up having some of these little artifacts in here, or this cusping that happens. And of course, we could go in and get rid of that by maybe running another pass with a smaller cutter, isolating some areas to tool with a smaller cutter, and so on. But that would sort of defeat the purpose of what we're trying to demonstrate here. It would take more time to do that, or you could pop it off your CNC right now and maybe do some hand finishing. If we compare that to the times that we saw in using our molding toolpath, doing the traditional 3D machining would take about 1 hour and 25 minutes. And again, going back to our molding toolpath, we're really only shaving off about 5 minutes. But I believe that you would easily add much more time going in and cleaning that up by hand using a sandpaper or whatever you happen to do, or even running another toolpath. And this right off your machine, as we can see, looks really good. So for this kind of work, a molding toolpath is perfect and should really give you the results that you're expecting and make coming off with a nice looking finished part a little bit of an easier process. So let's just close this down. And we're going to save this one off for you as well. And we're going to call this example number 2. So you can have a look at this later. We'll save that off. And we're going to file and we're going to close this. For this last part of this tutorial, we're going to actually show you how to use a closed vector profile with your molding cross section. So if we go ahead and we open an existing file, and you're going to look in your molding toolpaths tutorial folder for molding toolpaths frame example. So if you click that and you select open, we'll see right away in your 2D view we have this nice looking outline vector here, and then we'll take a look at our job setup. So it's a single-sided job. It's 40 by 40 by 1. We're going to zero off our material surface. Bottom left-hand corner will be our XY datum, and very high resolution, but that doesn't matter because we're not actually creating any 3D models, so that doesn't have any bearing on the quality of the output we're going to get. And we'll just click OK. Now, as we know, we're going to need 2 vectors. We also need a cross section. Now, if you've downloaded and installed all of your clip art that comes free with your software, if you look in your clip art tab, there will be a folder here called molding profiles. And we have some profiles here already for you ready to go that might be useful. But for this particular demonstration, we're going to go ahead and import in the same profile we used for the last demonstration. You'll see now it's down here in the corner. So let's just jump over to our Toolpaths tab, and we are going to step right into our molding toolpath. So if we select our drive rail and then our cross section, you'll see that our cross section is being hung on the outside of our drive rail. And if we want to hang it on the inside, you would expect that if we said reverse directions, that's what would happen. But in this case, that does not happen. In order to have the cross section go on the inside of this drive rail, you'd actually have to offset this external vector inwards by the width of your cross section and then use that as your drive rail. So in our case, we're going to make our gap above 0.05. That's going to leave us 0.2 at the bottom. We're going to select a tool. We're going to use a 1/4 inch ball nose end mill. Select that. We're going to use a larger area clearance tool, so let's use our 1/4 inch end mill. We'll select that. We're going to skip flat areas. We're going to machine our flat regions. We're going to leave a machining allowance behind of 0.03 of an inch. We're going to use our own boundary offset of 0.1, and we are going to calculate that. And right off the bat, you can see that we have rounded corners. And if we preview all of our tool paths, that translates into a frame with rounded corners, which doesn't look that bad. But let's say we did want to put in nice, sharp, mitered corners in there. We can go back into our profile and we can choose this option right here called Create Sharp Corners. And we can calculate that. We'll reset our preview and we'll preview our visible tool paths. And you can see when you looked at the tool paths, they were nice and pointy. And in our finished toolpath, they're nice and sharp. Now, you want to keep an eye on this because if you have any outside radiuses, sometimes you'll end up getting some results that are unexpected. So keep a look at those and make sure that everything looks as expected. And that looks pretty good. Now for a second, let's go back to our 2D view. Let's say we wanted to change the profile. We want to hang the other end of our profile off of our drive rail. Let's select that. Let's just go back into our actual molding toolpath. We'll right click on that and we'll reverse the direction, recalculate our tooling, reset our preview, and we'll preview our toolpaths. And you'll see that we've reversed the cross section, so we have a different look to our frame, but it still looks quite nice. Now in the end, of course, a frame isn't any good with the center still in there. So let's just go ahead and remove that. Let's go back to our drawing tab, look at our 2D view. Let's select our drive rail and we're going to offset that out the width of our profile, which happens to be 4 inches. And we're going to use sharp corners and we're going to offset that outwards, close that down. We'll go back to our tool paths and we're going to use these 2 vectors. So holding down our shift key, we'll select both of them as a profile cut to actually cut this out. So let's go ahead and choose our profile toolpath. We're going to go down our full depth of material. So if we put Z in here and press equals, it'll put in our 1 inch depth for us. We're going to select the tool. We'll use our 1/4 inch end mill. Select that. We're going to go outside those lines. We're not going to do a separate last pass. We're not going to add any tool or any tabs in, but you certainly could. Let's just go ahead and calculate that. And let's preview that tool path. And then we can double click on our waste material and you can see our lovely frame that we have left. And so with that, concludes this demonstration. We're going to save this off so you can have a look at this when you get some time. We'll save it off as example number 3. We'll name this 3 and we'll save this off in your Molding Toolpaths tutorial folder. Click Save. And now think outside the box with our Molding Toolpath. You can use this for all kinds of different edge treatments, for all kinds of different things. So keep that in mind when you're developing your strategy for cutting your parts. You never know when the Molding Toolpath will come in handy.